This is my topic for today. So I'm going to kick off the image processing and computer vision track for you today. There's a number of interesting topics. We're going to talk about what's new in image processing and computer vision in our products. We're going to talk about the GPU coder workflow. I'm going to talk about a little bit of highlights. I wanted to give you some insight into the kinds of things that we're working on at MathWorks and the kinds of applications that we have in mind when we're developing our systems. And really, it's pretty interesting how broad a set of customers we have who are using our tools today for image processing and computer vision. It wasn't too long ago, actually, that automotive wasn't even interested at all in image processing, and now it's a key part of what they're working on these days. And as well as many other areas. Agriculture has been taking off in their use of imaging, and as well as even retail. So the things that I wanted to talk about in my talk here are 4 workflow challenges that we're trying to address with our tools in our latest releases, and you're going to see these trends keep coming in future releases as well, although there are no spoilers about what's coming in future releases. First is the massive amount of image and video data that you're dealing with in your workflows. Time was many people had a 512 by 512 pixel image. Those days are long over. A couple megapixel is bare minimum. We've seen images as big as 100,000 by 100,000 images. These are things you can't even just load into MATLAB. You have to work on them a chunk at a time. Interactive workflows without coding. There are a lot of times when I assume everyone in the room here uses MATLAB or is thinking of using MATLAB. And MATLAB, as you know, is a programming environment. So why do I say without coding? Well, you don't want to code everything. There's certain things you just want to do and get done. And I'm going to show you a couple of the things that we've been doing to help you do that. I'm also going to talk about using MATLAB and open source together, specifically for image processing and computer vision workflows. And then talk a little bit about integration of algorithm development into product development workflows. So the first challenge is the massive amount of image data. There are cameras now, many cameras, even consumer cameras, have 20 megapixels or more, right? Video is now 4K or 8K in resolution. This is huge. And often for many applications, particularly for deep learning, you may have thousands to millions of images or videos to process, right, where you're working through terabytes of data possibly. So here are some of the things that we've been working on at MathWorks over the last couple of years that you might be interested in. First is image data store. This is a way to get your code around a large data set. Image data store is a MATLAB object that you set up that you can use, and then you point it at the directories of your images. It works through it, keeps track of them all. And then you can treat that as a variable that you can then run and use and you can read from, and then you can write to it. And that way you can work with an entire data set much more simply than in the past, where you used to have to keep track of file names and do a little bit of string magic. Second is the image batch processor app. This is part of the no-coding workflows I'm going to dive into in a little bit later. So you can use image data store with this behind the scenes, but this app allows you to select a bunch of images, decide on an algorithm, and run a function on them. Okay? It's got an interactive interface. It supports parallel processing. And so this is going to make it easy for working with large sets of images. And it's the image on the upper right that you see there. And then finally, I want to let you know that we've been working on volume visualization with our Volume Viewer app. This is particularly critical for medical imaging applications, but there are many other applications where 3D volume visualization is important. And so this is brand new. This isn't the old volume visualization that you've seen that was ISO services. These are voxels. Okay? And then finally, block proc. This is something we've had for quite a while. This allows you to tile up images and work with it a chunk at a time. And this is the area where you should stay tuned in the upcoming release. Okay, another thing you would want to do with a large set of images with very big data is be able to process it much faster. To that end, we're now supporting GPU acceleration on NVIDIA GPUs. You may already be aware that it's supported in hundreds of MATLAB functions, and now more than 50 of the most popular image processing functions use it as well. This is just a short list of the functions. It's actually more than this. Even going beyond GPU support in the products, we now have, this is brand new, this is only maybe about 9 months old. We now have a container in the NVIDIA GPU cloud, that's NGC, Docker repository, a container that has image processing, computer vision, signal processing, deep learning, statistics, pretty much anything an imaging person would need. This container can be run on Azure, on AWS, on DGX boxes. This is a very easy way to use our tools on some very high-end hardware. So for Azure and AWS, this is best used on their GPU instances, and then with the DGX hardware. What we're seeing is that the people that are supporting this hardware at various accounts where the hardware is being sold they don't want people to install MATLAB directly onto the hardware. They want to be able to use Dockers and containerization. And so we've enabled that. And this is something that is part of everyone's license. You can just use your regular license with it. You would log into the container. Depending upon the license type, with an individual license, you would log into it. With a concurrent license, you'd need a little help from your IT department to be able to tunnel through to your license server. So we're putting this out with every release. The container generally comes out a couple of weeks right after the release, but it's available at the address that you can see down here below. All right, the next challenge, interactive workflows without coding. So there's certain things you want to do where you don't want to write code for it. Let's say you want to calibrate a camera, right? Be able to account for some of the geometric distortions in it, particularly in a cheap webcam. You don't want to write code to do that. You just want to calibrate the camera. Maybe you have a large set of data and you just want to explore it. You just want to see what's in it. You don't want to write a whole lot of code. Or you want to label ground truth on an image or video data set for deep learning, right? So we've been building apps. We now have about a dozen different apps in image processing and computer vision for interactive workflows without coding. Many of these apps do generate code, so once you figure out exactly what you like about what you've done, you can generate the MATLAB code, to be able to do that exact function. There's the image batch processor, which I mentioned before, but also some of our standard long-standing image processing algorithms, like for segmentation, or for morphology, or for blob analysis. These are now rolled up into apps, so that way you can quickly try things out and just see what you like. There are also more apps that you're going to find on our file exchange that other users like yourselves and some of our application engineers have written. One example I've listed is one called Circle Finder, written by one of our application engineers, Brett Schulson, making it very easy to find circles of certain sizes just through some pointing and clicking in the app. And then that can generate some MATLAB code. Some of the advantages of app-based workflows, well, obviously, exploration without coding. It does increase your productivity. So before we made the camera calibration app, for example, there was a camera calibration toolbox available from a graduate student at Caltech that lots of people used, and it worked in MATLAB. But that took most users about 2 or 3 days to be able to calibrate their camera with it. We took a look at that, and this is actually going back a number of years, and we said we could do better if we make this into an app. So instead of taking a couple days, it's now 15 minutes. You don't need a ginormous checkerboard like one of our programmers has here. You could have just a smaller one. But still, you use this checkerboard, which we provide in the toolbox, the image, you would print that. And then you can use that to calibrate your camera. You have to take about 20 to 40 pictures or so. And this helps with, these apps also help with workflows that require some validation. Sometimes you need to look at the results. So you need to, maybe you'd use the image batch processor, run it through a bunch of images, and then you just kind of want to spot check to make sure that it's working right as you're figuring out whether your algorithm is working, and this is still in the exploration phase. So this isn't validation in the true test and validation sense. This is more of just making sure that your algorithm is working by looking at some of the data. So just a quick side note, I wanted to let you know something that a lot of people are aware of. You probably know that we support webcams. We've been supporting them for quite some time. But what you may not know is it's directly in MATLAB now. It's a hardware support package. Almost every piece of hardware that we support now, we support them through these things called hardware support packages, okay? Even in our toolboxes as well. And so it's a support package that's available directly in MATLAB or for use in MATLAB, and you don't need any toolboxes to use it. And the same with IP cameras, okay? So what we're doing is we're moving commodity hardware, mass market hardware, support down into MATLAB from the toolboxes to try and keep it simple for most users and make it widely accessible. The third challenge is using MATLAB and open source together. So here's an example of a research paper recently published that used Caffe and MATLAB together, and it achieved significantly better results than an engineered model. So in this case, what they're doing, they have the original image on the upper left. It's rainfall, and it's pretty heavy rain by the looks of it. And they're trying to see through the rain to get to some of the details. As you can imagine, this is not as interesting just looking out at your street, but if you're in a car and it's raining hard, you want your car to be able to see better and to be able to see all the details and detect all the objects on the road. So this is a critically important application. And what they were able to do was to use a deep learning model to be able to see the railing better, as you can see in the lower right corner. And what's most interesting about this to us is that they used both Caffe and MATLAB together. And I'd like to talk a little bit about that in a second, about that specifically. But first I wanted to mention that, and this is another thing people don't know about, we've had this for quite some time, and we've been keeping it up to date with every release, is our MATLAB OpenCV interface. This allows you to bring in OpenCV C++ code into MATLAB. So it uses MEX. It can also work with MATLAB Coder. So this is using OpenCV version 3.4.0. And we provide in this package all of the data type conversions that you need to be able to bring in the OpenCV data types into MATLAB and to export data. This makes it a whole lot easier to work with OpenCV code, which we know most of you are doing. A lot of people doing it. I mean, the OpenCV is free, right? There are all sorts of new algorithms that come up in it. There are some things that it does well. There are some things that it doesn't do as well as MATLAB. So you want to be able to use both together. Speaking of using both together, this is what I was talking about before, where they were using MATLAB and Caffe together. So there are two different ways in which we're supporting the use of artificial intelligence work frameworks along with MATLAB. One is model exchange. This is using the ONNX format, where you can build an ONNX model in PyTorch, in Caffe, in any one of these different frameworks, and then that ONNX model can then be imported into MATLAB, okay? Another way is also that we have some direct, as you can see, slightly different colored inside of the model exchange box, but slightly different colored brown importers directly from TensorFlow and Keras and Caffe. So we have direct importers for models into MATLAB. And you might think, well, what would you want to do with a model in MATLAB that's already out there in Caffe? If it's already in Caffe, why do I need to use it in MATLAB? Well, what we're seeing is that a lot of customers really like using our tools for a few key things. One, we have visualization tools that are not available in these other frameworks, and that allow people to look at the network and evaluate results in different ways that you can't do with the other tools. And so they like looking at things and trying to understand it a little bit better. The other thing that they really like is our GPU coder workflow, which you're going to learn about later. This workflow allows you to take a model that once you can get it into MATLAB and then generate CUDA code from it, and it makes it super efficient as the code that you can get directly from NVIDIA, and faster than what we can do in TensorFlow. So those are the two key things. And model exchange is really important because it now means that it doesn't matter what framework you're using, what framework the person down the hall is using, you can generally share results. Okay? The other way in which you can use open source tools with MATLAB is by co-execution. We have the ability to call Python code from MATLAB. And actually, using the MATLAB engine, we offer the ability to call MATLAB code from Python. So these are two different ways in which you can use these two environments together. And it's not just with Python, it's with C, C++, Fortran, although I don't think there are many users of that interface these days, Java as well, and a few others. Speaking of that, here's calling other languages from MATLAB, just a couple of examples. Many of you are probably aware of using MEX, so you can use MEX for my magical function foo. You can use it with C++. Another thing you might not know is about coder.ceval. This is a function that allows you to bring C code into MATLAB, and what's cool about this is when you use MATLAB Coder, instead of using MEX, when you use this with MATLAB Coder, and you have MATLAB code, and then you've got a little bit of C, it can take the whole thing and generate C code from it with that C function that you brought into MATLAB. And for C, C++ libraries, you probably are all familiar with our load library or call library functions. We have a new interface for C++ though, which is the clib.foo. Okay? This allows you to use C++ in MATLAB. This is within the last couple of releases. And then as I mentioned before with the Python interface, py.foolib would be the library that I made for foo, and then foo the function. And as I mentioned before also, you can call MATLAB from other languages. There's the MATLAB engine API for C, C++, for Python, and for Fortran. There's also our automation servers if you happen to be using COM or .NET. Okay. These interfaces have been around for quite a while, although I believe we updated the C++ interface here for the MATLAB engine recently. So challenge number 4 is integration into product development. Right? This is just some of our customers, and actually some of them I think are based here in Israel, like Respiri. And some of the customers that have used our tools to not only develop algorithms, but also bring that into the product development process. I know a lot of times customers think, well, MATLAB's great for building algorithms, but I have to rewrite it in C or I have to do X in order to get into production. And I want to tell you that there's a lot of capability in MATLAB now, in our coder products, in our fixed point capabilities, to be able to generate the code that you need for product development from MATLAB. So here's the workflow, right? You develop an algorithm, you want to build a prototype, you want to build an implementation, and you've got some existing code you want to work with. The problem is that you've got a couple of brick walls here, right? You need to be able to create reference C, C++. You need to do visualization and testing. And you need to integrate C and C++. I'm going to talk through how we're breaking down those walls. So first, as I mentioned before, you could take an algorithm. In this case, it's edge detection. You can combine it up with some other C code that you have, some existing C code. And then you can generate C, C++ code for that entire project altogether using the ceval function for MATLAB Coder. It also works in the opposite direction by using the ceval function. You can bring that code back into MATLAB for further algorithm development. There's a little bit about this workflow that people sometimes miss, which is that it closes the loop. It allows you now to not just go from MATLAB to some C, C++ code, but you can bring that code back in. You can say, okay, I really like this code. This is exactly what I want. If we're going to do algorithm development, I want it to be around or against this code, and bring that back into MATLAB. And by having that closed loop now, MATLAB can become part of your production environment. You can also use the MATLAB engine for visualizing and testing C and C++ from Visual Studio or Eclipse. This is one of the uses of MATLAB engine, okay? So you've got a couple of, that's engine.h you can see up there, a couple lines down in the includes, and that's the MATLAB engine header file, and that allows you to call MATLAB from within Visual Studio. This is running a Visual Studio project right now. Well, this is from a Visual Studio example. It's just a screenshot. And what we're doing here is just bringing in, we're running some code for a Gaussian 3x3 in C, and using MATLAB to do some evaluation of it. Right. So the way this works, this framework is, you've got a function in C. So this is from a C++ perspective. And this is how you would use MATLAB for testing. You've got a C function, your function here. You could do some input pre-processing to feed that function to maybe represent what kind of data your camera is sending into your algorithm, rather. And then you could do some output visualization of the results and do this entire workflow inside of MATLAB, while also being able to do, so this allows you to do prototyping, testing, and verification. Another thing that I haven't mentioned on the slides yet that you should take a look at is our unit testing framework. This is another one of the hidden gems inside of MATLAB that's been slowly growing every release that has capabilities for helping you with testing and verification. So when you want to get to real hardware, we're supporting older hardware, Raspberry Pis, Arduinos, student hardware that is. We support cameras. We're also supporting brand new hardware like these rapid prototyping boxes from NVIDIA. These are the Jetson and Drive platforms. And this is what I mean when I talk about hardware support packages that we provide. These are the kind of hardware that's available for use. And these you would be able to run, because they have ARM processors in them, you can run C code that you generate from MATLAB, C++ code, and you could also use it with GPU coder, as Lauren's going to show you later, a little bit later. So here's just a quick video of the demo. It's, I believe we're looking in a room here, we're doing a disparity map, just showing the depth, and it's running on the board. Okay. All right, so we talked about visualizing C and C++ data with MATLAB in Visual Studio and in Eclipse using the MATLAB Engine API. We've talked about MATLAB unit testing framework. One thing I haven't mentioned is our ability to identify runtime errors with static code analysis using the polyspace products. I believe we have a talk on that in the model-based design track if that's interesting to you. But that's not a typical topic for an image processing track. All right, so here's the typical development workflow with all the walls you have to get over. With MATLAB Coder, you're able to generate reference C++ code. With MATLAB Engine, you can do visualization and testing of C and C++ in Visual Studio or Eclipse. And with MATLAB plus MATLAB Coder, you're able to take existing code, bring it into the algorithm development process, bring it into the prototyping step. And also, I didn't include an arrow from implementation. You can bring it, it goes actually down to your existing code base and then can come back up through into algorithm development. So here are some resources that you can use to be able to get started on this product development workflow. The web page to look for is MATLAB and C++ resources. Lots of videos and examples. So far we've talked about massive amounts of image and video data and the new tools we have for that. Talked about apps that help with interactive workflows without coding, using MATLAB and open source together, and integration into product development. So throughout the sessions today, you're going to see more details about many of these. I believe Roy's going to cover a little bit more about apps, right? And Lauren's going to be covering more about GPU Coder. And we have a guest speaker from NVIDIA as well, who's going to be talking about how our tools work with NVIDIA hardware.